Hello, this is Unit 1, Lesson 2. We're looking at function operations and notation. Starting with function notation, hopefully this looks familiar to you. This is something you should know. It's something we looked at in the prerequisite knowledge review and quiz. But very important for the whole year. So we want to make sure everyone understands it and we're all on the same page. All right, so the first thing we want to look at is how these are written. So you see f of x equals negative 2x minus 1. We have g of x equals x squared plus 2. We have h of x equals negative 1. All right, so these are all functions. Even though they don't have f in it, like this one, it means the same thing. It's just a different name, okay? So g of x is still a function, it's just we call it g. H of x is still a function, we just call it h, okay? That's the first thing. The second thing to remember is when with function notation, we say f of x, g of x, h of x, etc. Okay? So this just means that f is a function of x. What does that mean? It's just fancy speak for x is the input, and you get a value out, and we usually call that y, okay? So it just means you put x in, and you get a value out for y. Since it's a function, it means you put 1x in, you get exactly 1y out, okay? So when we say something like find f of 5, what's that mean? We're saying we want you to evaluate f of x when x equals 5. Okay? So to do that, you take 5 and you substitute it in for x. So f of 5 equals 2. You put a 5 wherever you see an x, and then write the rest of the function. So I get 10 minus 1, 9. So that means f of 5 equals 9. Or when x equals 5, y equals 9. Okay? Let's look at g of x. Same idea. We want to do g of 5. So g of x equals x squared plus 2. That means I say 5 squared plus 2. 25 plus 2 is 27. All right, so g of 5 equals 27, or when x equals 5, y equals 27. Okay, h of x equals negative 1. What's the first thing you notice with this? What's this missing that the other two have? There's no x. Okay, so when h is 5, what's that mean? Okay, if you graph it, remember the line y equals negative 1. I could just rewrite this, y equals negative 1. It's about right here. So y always equals negative 1. It doesn't matter what x you pick. I could put x equals negative 10, x equals 0, x equals 5. Y is always negative 1. So no matter what you put in, no matter what you substitute for x, you're always going to get negative 1 for y. Okay, some things to note here. Notice I'm using parentheses when I'm substituting. Very important, especially when you're working with different values, you're working with negatives and distributing. Keep your work organized so you don't make silly mistakes. Okay, so there's 3 more problems below this. F of negative 2, g of negative 2, and h of negative 2. Go ahead and try those. Pause the video and try them. And when you come back, I'll have the answers for you. All right, you may have, so when you have f of negative 2, you should get negative 5. In other words, when x equals negative 2, y equals negative 5 for this function. For function g, when x equals negative 2, y should be 6, okay? H of negative 2, like I mentioned, it's always going to be negative 1 because h of x is negative 1 no matter what you put in for x. It's a constant. Okay? All right, very good. As we go through this, there's something you didn't quite understand, you got something different, circle it, draw a question mark to it, maybe a different color or highlight it. When you come to class, you can ask, okay, before you start the classwork. All right? Okay, so down here, if you saw this and said, well, what's going on with this? Okay, that's kind of where we're headed with this whole lesson. Okay, if you notice on the back, there's some notation that looks like that. Okay, so by the end of this lesson, you'll be able to do this. All right? With that in mind, let's look at something called function operations. What's this mean? Okay, so all we're doing is we're combining two functions together. We use addition, we use subtraction, or multiplication. There is division, but we'll do that more with your rational functions. There's also something called composition. We'll do that when we do inverses at the end of this unit. All right, so let's look at what some of this means. Okay, so you'll be given different functions like you have down here. You may notice they're the same as above. Okay, that's intentional. So up here with addition, let's look at the right side of this equation here. F of x plus g of x. Well, that means I'm taking this function, f of x, and adding it to this function, g of x. Okay? This notation means exactly the same thing as this notation. Be careful with this. You're not distributing x, okay, when performing the operation. Makes it sound like you guys are doctors. No. Maybe. But right now, the operation just means addition, subtraction, or multiplication. Okay, this is how the question or the problem will be worded. We'll say perform the indicated operation. What that means is combine the two functions either by addition, subtraction, or multiplication, and then simplify. Okay, we always simplify in decreasing degree. Okay, what does that mean? So I'll show you right here. You have f plus g of x. That means f of x plus g of x. So f of x is 2x minus 1. Use parentheses. G of x is x squared plus 2. All right, so what does decreasing degree mean? Well, it means take the term with the highest degree, that's x squared. Then take the next degree, 2x, and then our constant, negative 1 plus 2 is positive 1. So f plus g of x, or f of x plus g of x, equals x squared plus 2x plus 1. We combined the functions, we simplified, we wrote it in decreasing degree. All right, let's look at f of x minus h of x. So f of x, again, is 2x minus 1. H of x is negative 1. Simplify. 2x minus 1. Minus and a minus is positive. Negative 1 and positive 1 is 0. You're left with 2x. The next one is f times h of x. Another way of writing it. Okay, it means the same thing. All right, so f is 2x minus 1. H is negative 1. Now you multiply. Negative 2x and positive 1. It's already in decreasing degree. It's already simplified. We're all set. Okay? So try this next one, h minus f of x, and see what you get. Okay, so you should get negative 2x. We're combining functions h and f by subtracting. Okay, we did that. We performed the operation of subtraction, and the result is negative 2x. Okay, so notice these are just, all these have x in. Okay, it's a function of x. I've got x in my result. Okay, unless you have two constants like we have with h, you should have an x in your result. All right. Why are you saying this? Okay, well the next thing we're doing is we're combining, performing the operation with evaluating. So back on the first page, when I said that's what we're working towards, this is it. Okay, so I have a new set of functions for you. You don't have to keep looking back at the first page. So we have h of 1 plus j of 1. All right, so why was I going on about you put x in, you should have x in your answer? Well, now you're putting a number in. You should get a number out. Okay, be very careful with that. Make sure you're paying attention to what you're doing. So perform the indicated operation, then evaluate. This could also just say, perform the indicated operation. And you should just know that since there's a number here, there should be a number in your result. All right, so h of 1 plus j of 1. Well, we know what h of 1 means. So h is x squared minus 1. That means we put 1 in for x, write the rest of the function. We're adding that to j of 1. All right, so not only are we evaluating, we're also combining the two by addition, the two functions by addition. All right, so j of x is x squared plus 4. All right, so I'm doing 1 squared plus 4. That's the setup. Okay? You could combine these and then evaluate it. What I'm doing is really doing it all at the same time. So I'm evaluating h of 1. 1 minus 1 is 0. I'm adding that to j of 1. 1 plus 4 is 5. 0 plus 5 is 5. Okay? So we're evaluating and combining through addition. All right? All at the same time. So g of negative 1, you could write this. G of negative 1 minus k of negative 1 means the same thing. Right? So g is 2x minus 3. So I put a negative 1 in for x. From that, I subtract k of negative 1. K of negative 1. Well, look, here's our constant again. There's nowhere to put the x. No matter what I put in for k of x, I'm going to get negative 3. So I put in negative 1, guess what? Negative 3. So simplify. Negative 2 minus 3 plus 3 equals negative 2. Okay, there's a couple of operations to try below this, down here. Go ahead and pause the video and try these, and I'll have the answers when you come back. All right, so g minus h of negative 1, again, the same thing. That's the same thing as saying g of negative 1 minus h of negative 1. You should get negative 5 as your result. H times f of 2. Same thing as saying h of 2 times f of 2. You should get 12 as your result. All right, check your work, make a note of any issues you have, bring those questions to the next class, and we will see you then.